What's up, guys? Kevin Brune, the fit rocket scientist here, coming to you with information on the Nobel Prize in Physics. So the Nobel Prize in Physics was just awarded to the LIGO Founders for the direct detection of gravitational waves. So there were two guys from Caltech and one person from MIT that founded LIGO. So we have Barry Barish and Kip Thorne from Caltech, and then Rainer Weiss from MIT. And these guys founded LIGO, and LIGO is what detected the gravitational waves, which awarded them the Nobel Prize in Physics. But you're probably like, what's LIGO and what are gravitational waves? That's what we're here for. So LIGO stands for Laser Interferometer Gravitational Wave Observatory. What's an interferometer? I know what a laser is. Gravitational wave, we're gonna learn about that in a bit. Observatory, you're observing. But interferometer, we get up the nifty whiteboard here. So let me get a little bit closer. Hi, how's it going? We're getting up close and personal here. Just want to say hi. My name's Kevin. If I haven't met you, nice to meet you. Laser interferometer. So you have a laser that shoots a beam, all right? And then there's a beam splitter here. So part of the beam goes up and part of the beam passes through, and they both hit mirrors and then bounce back. So the arrow shows it's going this way and then coming back. Beam splitter goes up, hits the mirror, comes back, and they split and then they collate, they come together, so as they're reflecting, coming back down, go through here to the observation point. I just kind of erased a little bit of my drawing there. And here we have an interference pattern. So based upon the disturbances that can go on in this system, we'll show you different types of patterns and shifts and wave functions that go on in this interference pattern. And observing this and what kind of changes it is how you detect the gravitational waves and other things. So LIGO is huge, it's the biggest one out there. This distance right here is 4 kilometers. 4 kilometers is how far apart the beam splitter is for the mirror. There's a couple other things that go along in there. There's a couple more reflectors and stuff, but this is like a basic simplified version of what a laser interferometer is. So now that we got that out of the way, so we know what they detected or how they were detecting it. So what did they detect? So gravitational waves are literally ripples in the fabric of space-time. So when you throw like a pebble in a pond and you see it go bloop, 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 like there's ripples in the pond, it's exactly what's happening with these gravitational waves in space-time. So everything is space-time, like it's all around. So it's just ripples in the fabric of space-time. So Einstein actually first predicted these in 1916 with his theory of general relativity. That's over 100 years ago now. We're in 2017. If this video is shown really, really far in the future, 2017 is when it was posted. And they are caused by like some of the most violent and energetic processes in the universe. So think of like supernovas, stars exploding, like stars combining, black holes combining together, or even the Big Bang, the start of our universe in general. Those huge events are what really send out the gravitational waves. But everything actually gives off gravitational waves. I give off gravitational waves, and so do you, but they are so minuscule and so small that it is impossible to detect them. But everything that has mass and an acceleration that can change its speed, increase or decrease, that's what gives off the gravitational waves. So the proof of their existence was actually found in 1974 by 2 astronomers in Puerto Rico. What they observed in the night sky was a binary pulsar system. So what that is that's 2 really heavy and really dense stars orbiting each other. And they observed this for 8 years, and they saw them getting closer and closer and speeding up. And what they noticed is that their observations of these stars and how their orbits changed and how they sped up precisely matched those predictions of the theory of general relativity, which in turn told us that there are these gravitational waves out there. So now fast forward, here we are 2 years ago, September 14th, 2015, we're at LIGO, and there is direct detection of these gravitational waves. So that interference pattern, these arms, they detected the disturbance, and they sensed the distortions in the space-time, which gave us the direct detection of these gravitational waves. Like, it's just awesome. And what we know is that it came from 2 black holes that were orbiting each other and collided 1.3 billion light years away. That's way the heck out there. 1.3 billion light years away, the black holes came and went together. So what we know is that current best knowledge tells us that there are 4 types of gravitational waves. And what we discovered here, or detected, was the compact binary in spiral gravitational waves. It's a long word, but there's 3 ways to go about doing that. And yes, Kevin's bringing Oreos into this video now. So the way that we can detect those, or that those get created, is two black holes that are orbiting each other. And as they're orbiting each other, they get closer and closer and closer to each other, and then they form one giant black hole that's just spinning super, super quick. So two coming together, boom, and then the gravitational waves are super intense and coming out. You can use the black holes or more Oreos. So, white. So neutron stars are very, 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 very hot. And if you could see them with the naked eye, they would appear white. So we got the cream. So they can be orbiting each other too, spinning up, getting faster and faster as they come together, and boom, they combine to form a giant energy release of particles, and that's where, boom, the gravitational waves come up. So you can do that. Third way, one of each. So we flip that around, and now we have a black hole and a neutron star in a binary orbit, and then the black hole absorbs the neutron star, boom. Then we got the full Oreo again, and it sends out even more big bursts of gravitational waves. So that's what it is. This literally goes down in history as one of the biggest human scientific discoveries ever, which is just amazing. So now that we got gravitational waves, grab your gravity board and we're going surfing.